Okay, hi guys. Today I would like to talk about RC circuits, different functions and the different types and shapes of this circuit, RC circuits. So let's start with what actually an RC circuit is. Well, an RC circuit is a circuit which consists of R, which stands for resistors, and the C, which is for capacitor. The easiest circuit that we can draw with a resistor and a capacitor is something which contains a battery, a resistor, and a capacitor. Let's see. We have two main types of RC circuits, which is mostly used. The first one is integrator, which has something like this, and these two pins are the outputs, R and C, and the second one, which is differentiator. The only difference between these two circuits is that the place of the capacitor and the resistor are changed. So, these are the basics of what actually an RC circuit is, and we would like to talk about what are the equivalent resistors in a circuit. We have lots of things which we can be easily solved by just knowing some simple rules. The first thing I would like to tell you about the resistors and the equivalents are when the resistors are in the series form. So let's imagine these two resistors, R1 and R2. So the equivalent resistor is R1 plus R2. But what if we have a series of resistors which goes, for example, we have n number of resistors in series. So here R equivalent, is the sum of all resistors. So this formula is for resistors in series form. The second one, I would like to talk about the parallel form, which has a form like this. Connected. 1 over R equivalent is 1 over R1 plus 1 over R2. This can be simplified to R equivalent equals R1, R2 over R1 plus R2. Like the previous one, I would like to also tell the formula about what if we have n number of resistors. Here, the equivalent resistor is 1 over R equivalent equal the sigma of 1 over R I from 1 to the n. One more point that I would like to also add is that in some circuits we have a simple wire, which we name it as W1, and a resistor, R1. we consider that the resistance of W1 is R. And we would like to calculate the total resistance of this part of the circuit, or we may call it R2. So we calculate this one equals 1 over R2 plus 1 over R1. But we know that in a simple wire, it's actually idealized that we have the minimum value of resistance, which means that R2 tends to 0. So if we want to correctly write this equation, that would be the limit of R2 goes to 0 of 1 over R equal, which means that we want to calculate this formula. We know that the limit of 1 over R1 exists, and we can take it out of the limit. So we can easily write it like as R2 tends to 0, the value of this function or this term would go to infinity. So if we want to write it just in order to understand what we are trying to say, it's 1 over R1 plus, let's call it infinity, equals 1 over R equivalent. So this here would go to infinity. So we can easily write it as 1 over R equal is infinity. So, which means that if we just inverse them, equals 0. This means that if we have a wire, the voltage difference between here and here, between here and here, is the same. If here is V volts, here is also V volts, because we don't have any kind of, we have current, but we don't have any kind of resistance in this wire. So IR for this resistor equals 0, as we have no resistance. So it seems like that we have a difference, we don't have a difference of voltage here, so it seems like that this resistor here, it's like that it's out of the circuit. So in this section, I would like to talk about the total capacitance of a circuit. Well, I would like to analyze first when two capacitors are in series form. So the equivalent capacitance is so if we simplify this equation, we would get this is a simple case for just two capacitors. But what if we have n number of capacitors? C1, C2, C3, and Cn. Here, in this case, 1 over C equivalent is the sum of all 1 over Ci, I from 1 to the n. The next option is that when the capacitors are in parallel form. So here, 1 over, C equivalent equals C1 plus C2 plus C3. But what if you have n number of capacitors? here, the total capacitance of this circuit on this part of circuit is the sum of all the capacitors and capacitance. These two formulas are so important for us.